We're using one of these special methods to count how many times a value appears in the list. Specifically, we're calling count on an item, apple, and it tells us that this particular list contains 2 apples. As we use pop on our list without specifying an index, the last item added, in this case, 7, is automatically removed and returned as the result, which you can see appears on screen as 7, showing up underneath the line of code. We're using a list as a queue, where the first element added is the first element retrieved. Watch Terry show up as the new last item in the queue after it arrives. We're creating a new list where each element is the result of applying an operation to each member of another sequence, and we start by creating an empty list for our squares. We're creating a variable named squares that will hold our result, and it starts out as an empty list since we're assigning it directly to an assignment operator, the equal sign. We can generate a list of perfect squares using a feature called a list comprehension, and here we're creating it by squaring each number in the range from 0 to 9 and storing them in this new variable squares. A list comprehension combines the elements of 2 lists if they are not equal, and here we use it to create a new list where each element in one original list is paired with an element from another, but only if the elements aren't equal. The variable combs is initialized as an empty list and then populated with pairs of numbers where each pair has 2 different elements. Watch the list grow to include these pairs. This code uses a technique called list comprehension for creating and filtering lists. Specifically, it doubles each value in the initial list to create a new one. List comprehensions can contain complex expressions and nested functions by using mathematical constants like pi, which is why this code uses 3.1, 3.14, 3.142, 3.1416, and 3.14159 as rounded values. The matrix is being populated row by row, with each new list containing 4 elements, so the first element of the second sublist will be 5. The outer list comprehension is transposing rows and columns of a matrix by swapping its indices. The list comprehension is used to create a new inner list, where each row of the matrix is iterated over and transformed by applying the operation to each element, which makes this example equivalent to using a for loop to iterate over each column in the original 4x4 matrix. Which operation is applied to create a nested list? In other words, for each item in a row, we take that item and use it as an index into another list. By unpacking the matrix into rows and columns with zip * matrix, we're effectively transposing the data structure to make it suitable for analysis, resulting in a new list of tuples where each tuple represents a row from the original matrix. Removing an item from the list using its index. We're deleting the variable a right now with del, which means we're removing it completely and getting rid of its value. Tuples may be nested in this way, where a list of values is paired with another list or value to create a new tuple structure. Empty tuples are constructed by an empty pair of parentheses. A tuple with one item is constructed by following a value with a comma, which is confirmed here when we create a single item tuple with hello and get exactly 1 as its length. Unpacking a tuple by assigning it to variables is the reverse operation, where we're splitting a packed tuple into individual values that can be used separately. Fast membership testing. Similarly to list comprehensions, we're using this same syntax for set comprehensions, and the result is a new set that includes only the characters R and D. We're creating a dictionary by using curly braces and comma-separated key-value pairs. Watch as we add initial key-value pairs to the dictionary with tel equals Jack, 4098, SAPE, 4139, and then insert another pair with tel Guido equals 4127. We're building a dictionary directly from a sequence of key-value pairs. Watch it get defined as a new dictionary called Guido with a value of 4127. We're using a dictionary comprehension to create a new dictionary where each key is squared twice, resulting in values like 4 and 36 appearing in our final output. It's often helpful to specify pairs using keyword arguments when working with simple strings, like SAPE here, which is paired with a numerical value 4139. Using the items method allows us to get both the key and value at the same time as we loop through the dictionary. We're using the enumerate function to get both the index and value at the same time while looping through a sequence. The index is assigned to I and the value to V. Zip pairs entries from lists of questions and answers to iterate over them simultaneously. The reverse function is used to create an iterator that can be looped over in reverse order, and we're using it here to reverse a sequence of numbers generated by range. We're sorting a list of items to loop over them in order, and we start by creating this list. Using a set to eliminate duplicates and then sorting it is an efficient way to get unique elements in order. Sometimes you might want to remove values that are not valid numbers when looping over a list. In this case, using math.isn't helps identify those invalid values. Here we use two Boolean operators, OR and comparison operators, to create a condition that's true if either of the strings is not null, and then assign this result to a variable named non-null, which shows us its value after evaluation. The walrus operator, equals, is used to assign a value to a variable inside an expression, avoiding common problems like this one: 1, 2, 3, 1, 2, 4, where if we didn't use the operator, the comparison would be done between the numbers themselves.